Hi and welcome back to Gaffy's Grinds. This is video 2 in our organic chemistry experiment series. Okay, if you haven't watched video number 1, I suggest you go back and watch it, where we were discussing the production of ethene gas and the production and the testing of its properties. In this video, we'll be looking at the production of Ethyne gas, and we will be looking at the testing of its properties. The usual reminder, when you're watching these videos, try and eliminate all distractions because they prevent you from learning by overloading your working memory, which is pretty small and can only hold a certain amount of things at a time. So if you're focused on something else that's coming up on your screen, or the temptation to go to Amazon and buy something new, or the temptation to flick to another video, eliminate those distractions now by turning off your phone, placing it in another room, and close any other tabs you have open. Just focus on this video as best you can. You will learn lots by watching this video, but only if you give it your full attention. The other thing is, the most important reminder is when I ask you to do things, questions, tasks, it's really important that you do them. That's the best way you can learn this stuff for the long term, is by practicing. And if you don't do that, then you're wasting your time watching the video. Okay, so let's get cracking into it. A quick couple of questions just to start us off. Before we start, we need to make sure you guys understand what gas we're making. We're making Ethyne. So what you guys should already know about Ethyne is you should be able to answer these questions already, because you should have been studying, or you should have been learning about the organic theory before we talk about the experiments. So I want to pause your video now, and I want you to try and do these questions. Okay, so you should only be watching the video if you have now attempted to do all of those questions. Don't leave anything blank, guys. Have a go, put pen to paper, and if it's wrong, who cares? We'll fix it. That's the problem. We prefer if it's right, but you know, we all make mistakes. So again, if you haven't done them, do not skip over this part. Just turn the video off, because you ain't going to learn anything. Okay. All right, so answers are coming up. Write the molecular formula of Ethyne. A reminder that the molecular formula is a formula that tells you the type and the number of atoms present. The general formula for an alkyne, this belongs to the alkyne family, is the CnH2n minus 2. The general formula for any alkyne. So if we've got Ethyne, okay, so eth means 2 carbons. Ine means it's an alkyne. Okay, so it's an alkyne. It's an alkene with 2 carbons. Sorry, it's an alkyne with 2 carbons. Right, so that means it has a general form. It has a formula of C2 because there are 2 carbons, and the general formula says it's the H's are 2n, so 2 times n, which is the number of carbons, minus 2. Well, 2 times n is 2 times 2, which is 4. Take away 2, which is 2. So C2H2 is the molecular formula of Ethyne. Well done if you got that right. Draw the structural formula of Ethyne. Well, you will know that alkynes, or you should know that alkynes have a triple bond. So it's C, triple bond C, and then there's 2 hydrogens, there's 1 on each carbon. Check the bonds on the carbons. Each carbon should have 4, and each one does. So you've got, just double check, count them all, make sure the carbons have 4 bonds, but I can see there that they do. So this is question 1, and this is question 2. Question 3. To what homologous series does Ethyne belong? Ethyne belongs to the alkynes. Ethyne belongs to the homologous series alkynes. To the alkynes. In the diagram you have drawn above of, that should say of Ethyne, sorry, that should say of Ethyne. Draw a circle around the functional group of Ethyne. Okay, so I'm going to draw a circle. I'm going to draw it in orange. The functional group of an alkyne is that it's got a C triple bond C. So this right here is the functional group. That's what you should have done. Well done if you did that. That's question 4. Number 5 then, what is a functional group? A functional group is an atom or group of atoms that give a molecule its characteristic properties. By now I expect that you know that. We've talked about that loads in my videos, in the previous video and in the videos where we talked about the different hydrocarbons. Ethyne is an unsaturated molecule. What does this mean? Unsaturated means the molecule contains a double or a triple bond. Good, so that's a little bit of background before we started into the production of alkyne, which is the production of Ethyne, sorry. Right. Now let's get on to discussing the actual experiment. How do we make Ethyne? Okay, well, Ethyne is made using the following setup. Okay. We start with a conical flask. So we've got a conical flask, which is a cone-shaped flask like this. This is a conical flask. It's a cone-shaped flask. In the conical flask, we are going to put our reactant, one of our reactants. I'm going to draw in gray because this is actually a gray solid substance. So a gray solid substance. Okay. It's a gray solid substance. And it's called calcium dicarbide. Calcium dicarbide is this substance. It's a gray solid. It's called calcium dicarbide. Okay. And it has the formula, so I may as well tell it. It's CaC2. Di means two, and carbide, it's got two carbons attached. It's a calcium with two carbons attached, so calcium dicarbide. Now, a little fact about calcium dicarbide is that they used to use calcium dicarbide in mine torches. So down in the coal mines before there was electricity, and they had before they had lamps and stuff like that, okay, like electric bulbs down in the mines, they used to have lamps made of where they basically would do this reaction that we're going to use. They would put calcium dicarbide into the lamp, and they would do a reaction with it. And the reaction then would create a gas, the same gas we're going to make, that actually could then be burned and produce a flame. Now, this particular conical flask, has an extra little bit, and that is it's got what we call a side arm. And a side arm is basically a collecting arm where gas can flow. So it's got a side arm. On the top of the conical flask, we're going to put a bung, a rubber bung. And on top of that, we're going to put what's called a dropping funnel. It is basically a funnel with a tap. This is a dropping funnel. And what a dropping funnel does is it allows us to keep a liquid. Up here, there's a liquid in here. And the liquid we're going to use in this reaction is water. So the dropping funnel allows us to use this tap to twist and just control the flow of our liquid, which is water. So our water is going to drop from the dropping funnel when we open the tap, and is going to drop onto the calcium dicarbide. And it's important that we control the rate so that we can control how fast this reaction happens. Why is it important to control how fast the reaction happens? Well, this reaction creates this kind of fizzing. Okay, so it's a fizzing. Now, a fizzing tells us that gas is being produced. It creates a fizzing. Now, a proper name, the proper chemical name for fizzing is called effer, E-F-F-E-R, vescence, effervescence. And effervescence is just fizzing. It means a gas is being given off. So when the water reacts with the calcium dicarbide, a gas is given off. Now, obviously, we want to collect that gas. So the gas is going to go up, and it's got nowhere to go until it finds this side arm. And the gas is going to leave and go out the side arm. So it's going to flow this way. Now, we're lucky in that we can put a tube on. Like before, we have a collecting tube, and we're going to collect that gas. Now, I told you about the lamps in the coal mines. Well, in the coal mines, when they dropped the water onto the calcium carbide, they would then have a little device with a spark that could set the Ethyne on fire. And then obviously the gas, which is flammable, it has to be flammable if it's going to burn, then gave off light. Okay. But here we're not going to light it straight on fire. We're going to collect it first. Another important, one more thing is that this reaction vessel, it gets hot. It gets very hot. Okay, and you can actually see some water kind of evaporate. You can almost see a smoke in there. It's because the water vapor that's being created is turning into a gas pretty quick because the reaction is quite hot. Now, when a reaction gets hot, okay, what it does is, so say we've got our reactant calcium carbide here. What's happening here is energy is being given off or released from the reacting calcium carbide and water, and it's been given off to the surroundings. We say energy is transferred to surroundings. When energy gets transferred to the surroundings, it feels hot because you are the surroundings. If you put your hand on the flask, you are the surroundings. So energy has been transferred from this chemical reaction, from this reacting set of chemicals, it's been transferred into your hand. Okay, that's why it feels hot. A reaction that does this is called an exothermic reaction. Why exothermic? Well, thermic refers to thermal energy. Thermal energy. Exo is like the word exit, so gives out or leaves. It means gives out. So this is a reaction that gives out thermal energy. So that is something you would observe by feeling. You would observe that the flask gets hot. You would also observe fizzing. You would actually hear it, and you would see the bubbles of gas being formed. So you would observe this during the reaction. In the manufacture of calcium dicarbide, there are some other chemicals in here that we say they are contamination. Okay, these are contaminants, or we sometimes refer to them as I want to give you the right word here. Impurities. There are impurities in the production of calcium dicarbide, which means that when we react these two things together, we get some impurities that we would like to remove. Why would we like to remove them? Well, they're not very pleasant. So we can bubble this mixture or the gases that we produce. We can take them, just going to actually, we'll take them and we're going to bubble our gas through we'll connect it to the top of this tube. This tube is going to basically connect. This isn't going to be a very good diagram because this is in my way. I'm just going to remove this, please. Sorry. This tube is going to connect to, say we've got a boiling tube, and at the top of the boiling tube we've got our stopper, and this tube is going to connect in here, and it's going to go down, and we're going to bubble it through a blue solution of what we call copper sulfate. This is acidified copper sulfate. And the reason why we're bubbling through the copper sulfate is so that the impurities will react with the copper sulfate and stay there. So this is copper sulfate. And it's acidified to allow it to react better. So it's acidified copper sulfate. So when our impurities and our gas, our Ethine gas and our impurities bubble through the acidified copper sulfate, the Ethyne gas is allowed to bubble through and continue on, but our impurities react with the copper sulfate and stay where they are, stay in here and get trapped by the acidified copper sulfate. So the acidified copper sulfate, it traps impurities. What are these impurities? Well, they are sulfur-containing compounds. Okay, and we again, I'm going to give you the names now. They are phosphine gas. Okay, phosphine gas and sulfide, hydrogen sulfide purities. We've got hydrogen sulfide. We've got ammonia. And we've got phosphine gas. And all of these chemicals can be quite toxic and pretty bad smelling, okay? But they can be toxic. So it's important we don't just allow them to just bubble into the room that we're working in. So hydrogen sulfide, ammonia, and phosphine gases need to be removed. Now I'm just going to give you the formulas of them. Hydrogen sulfide is H2S, ammonia is NH3, and phosphine is PH3. So these three gases are made in this reaction, and we just want to trap them and remove them. We then, just like we did with the ethene in the previous experiment, is we're going to collect it over water. So I'm hoping that you've already watched that video. This is a water trough like this, and we've got our beehive shelf, and on top of our beehive shelf we've got a test tube full of water. So this is a beehive shelf. Our delivery tube is bringing our Ethyne here. Delivery tube is delivering our Ethyne to the water basin. And we are going to bubble our gas up, and it's going to collect above the water. It's going to collect over water. So this is a water basin filled up to here with water, a water trough. I'm going to collect our gas over water, which again tells us that this is insoluble. Because if it wasn't insoluble, it would just dissolve and it wouldn't collect on top like this. It would just mix in with the water. So this is our insoluble Ethyne gas. Ethyne gas has a sweet smell, like the ethene did. It's a sweet smelling gas, and it's colorless. So you won't actually be able to see it in here. It will just look like it's empty. Okay, but there is a gas there, and we will allow the test tube to fill with gas until it pushes all of the water out. We would then stopper it and collect another one. So we want to collect about 4 to 5 tubes. Need to be collected. 4 to 5 tubes are collected. Okay, I'm pretty sure that we have done enough detail there for you guys to be able to answer the next task. So what I'm going to do is I'm going to get you guys now at this stage to pause the video, and I want you to write out this paragraph, okay, and I want you to fill in all of the key words. So pause the video and do that now, please. Okay, so you should only be watching the video if you've written out the whole paragraph, not just the blanks, because this is practice for you to get good at writing out full answers. So this is helping you practice your science writing, okay? So let's check the answers. The answers will show in red here, okay? So this is what you should have. I'm pretty sure that we covered all of that, okay? So well done if you managed to do that, if you managed to get it right. Oh, the one thing I noticed that I did not explain, so glad I caught this here now, is this here. A white colored substance is formed in the reaction. Apologies, I did not explain that. So you guys, that's not your fault. That is my fault. So over here, I'm just going to get rid of this for a second, make some more space here. The gray solid is the calcium dicarbide. But after it reacts, okay, it turns into a white foam. This is calcium hydroxide, CaOH2. So some of the atoms from the water molecules on top are displacing the carbon molecule. So the carbon molecules was attached to the calcium before. Some of the OHs from the H2O are displacing the carbon. Okay, so the carbon is getting displaced. Okay, and then we are forming calcium hydroxide is the name of this chemical. So calcium hydroxide. So apologies, I did not explain that properly first time. All right, you should have we have some questions to do now. So here we go. Let's pause the video now and have a go at these questions 1 to 11, please. Do that now. Okay, so you should be watching the video now if you have answered all of those questions. I appreciate that they take a while, but it's worth your while practicing drawing them diagrams and stuff, because you do get asked to do that in the exam, and it just aids your understanding quite a lot. So first question says, calcium dicarbide is used in this reaction. Explain or describe the appearance of calcium dicarbide. So calcium dicarbide is a gray solid. What substance is reacted with calcium dicarbide? That would be water. Effervescence is observed during this when the substances react. What does this mean? Effervescence means fizzing. Effervescence is fizzing. The reaction is exothermic. What does this mean? Well, exothermic means the reaction releases energy to its surroundings. So well done if you got them right up to now. Draw a label diagram of the apparatus set up in this reaction. So I'll scroll back over here where we've drawn that. This should be your label diagram of your apparatus. What do you need to have in here? Let's do a quick checklist. So you should have these words. You should have labeled a conical flask and a dropping funnel. You should have labeled delivery tube, beehive shelf, and I suppose this here is a test tube, and a water trough. These are the pieces of equipment that you're going to need. So quickly go over them again. Dropping funnel, conical flask. This is another test tube, I suppose. It's a test tube or a boiling tube. You've got a delivery tube, a test tube here, a beehive shelf, and a water trough. Okay, so you should have all them pieces. Then we need to think about the chemicals. We've got calcium dicarbide, so you need to have that there, calcium dicarbide. Acidified copper sulfate, and this is obviously water, and then insoluble in ethine gas, or just ethine gas will probably do. Okay, so there's your checklist for what you need to have in your diagram there for it to be a fully labeled diagram. Number 6, it says the products of this reaction are ethine and calcium hydroxide. Write a word equation for this experiment. Okay, so let's think about it. We've got calcium dicarbide, and we're reacting it with water. So those are our reactants. I've given you the products. The products are ethine and calcium hydroxide. So ethine plus calcium hydroxide. All right, well done if you got that right. Okay, and then write a balanced symbol equation for this reaction. Well, calcium dicarbide is CaC2. Water is H2O, like that. Given you ethine is C2H2, and calcium hydroxide is CaOH2. Now, if you were able to do that already, great. If you weren't able to write out those symbol equations, you could pause the video now and try and balance it for me. Okay, all right. It's not a balanced equation at the moment. To fix this, it's quite a simple fix actually. The carbon, there's one carbon here and there's one carbon here, so those are good. Sorry, the calcium, sorry. There's one calcium on the left, there's one calcium on the right, that's good. There's 2 carbons on the left and there's 2 carbons on the right. That's all good so far. Here on this side, there are 2 hydrogens here and there are 2 times 1 hydrogen here. Okay, so that would be 4 hydrogens in total. On this side, I've only got 2. So if I make this a 2, I've now got 4 hydrogens on the left. Last thing to check is our oxygens. I've got 2 times 1 oxygen on the right, which is 2 altogether. And I've got 2 times 1 oxygen on the left. So balanced, that is now balanced. Okay, so I'm just going to get rid of these ticks now. I've mistakenly wrote out some of this, so this should be this should be C2H2. C2H2, and this is correct now. Okay, so that is your balanced equation. You just needed a 2 in front of the H2O. All right, and then the next couple should make sense to you yourself. Okay, just let you have a read through them. So from 8 down to 11, just check your answers. All right, and right, then we are going to discuss the tests that we do on these gases. The test that we do on this gas. Now, we've got our 5 tubes of Ethyne gas collected. We've got our 5 tubes. The first thing we're going to do is we're going to do a combustion test. So just like we did for Ethine, combustion test, we're going to take our test tube of Ethyne gas. So these bubbles or these molecules, particles show us Ethyne gas. Okay, we're going to take a lit splint on fire, and we're going to combust the Ethyne gas. When we do this, we get, it does combust, we do get a chemical reaction. We get Ethyne gas, C2H5, or H2, sorry, this is Ethyne. And we know what gas do we always need when we're combusting a fuel? Speak your answer now on 3 to the screen, 1, 2, 3. Ethyne always combines with oxygen. So plus the chemical formula or the symbol equation for oxygen is what on 3, 1, 2, 3. Should have be O2. So C2H2 plus O2. Okay, so when we combust it, gives you. Now, what are our products when we combust a fuel? What are our products always? Same 2 products. On 3, what are the products of combustion? 1, 2, 3. Hoping that you said carbon dioxide plus water. Okay, so the formula for carbon dioxide is what on 3? 1, 2, 3. You said CO2 and water on 3. 1, 2, 3. H2O. Okay, what I want you to do now is I want you to pause the video. I want you to take that bit down and I want you to try and balance that equation for me. On 3, 1, 2, 3, pause the video. Okay, so hoping that for a balanced equation that you did this 2, 5, 4, and 2. That is it balanced. I hope that you were able to do that. If you were not able to do that, then you need to go and watch the video that I have made on how to balance an equation, if that is not clear. Okay, right, so that is the combustion of Ethyne to make Ethyne in oxygen, making carbon dioxide and water. Like we did in the previous video, we can do a test on this, on the products to see if carbon dioxide is present. We would expect it to be present if we have just combusted a fuel. To do this, we would take our reacting, or what we were left over with, which is our test tube after the Ethyne gas has burned. Oh, sorry, I'm just going to stop there. Okay, I never said what our observation was. What do we see when we burn our Ethyne? Observation. Well, we do get a flame. We do get a flame because it does burn. I just want to refer to the structure here. You see this? This is the structure of Ethyne. And I'm going to compare it to the structure of Ethine. This is Ethine. Ethine and Ethyne. Now, Ethine burned with a luminous flame. I want you to think about when we are at home and we light a fire, what's left on our chimney or around our fireplace afterwards is this black substance, a black dusty substance that we call soot. Soot and smoke form when carbons do not burn efficiently. So when carbons remain unburned, you get soot or smoke forming. Now, because the carbons here are doubly bonded in ethene, double bond, and they are triple bonded in Ethyne. The Ethyne burns less efficiently. Okay, so the Ethyne burns less efficiently. This is because of the triple bond instead of the double bond. Less efficiently or less completely. that means that more of the carbon is left over. And carbon is this unburned carbon, looks like this black substance. It's actually the same substance that you get when you burn your toast. So if you leave your toast in for too long and it goes all black on the front, that's because the carbon in the bread is unburned. It doesn't burn properly. And it's unburned carbon gives you this black color, okay? So because of the triple bond, this carbon actually doesn't burn completely as ethene, which means it looks black. Looks black, like soot or smoke. And you get soot or smoke. Now, that means that when we burn ethine, instead of a luminous flame, we actually get a smoky or a sooty flame. Smoky or a sooty flame. So that's the observation that we make when we burn ethine. Ethene is a luminous flame. Ethine is still bright, but it's got this soot or smoke that comes along with it because the carbons don't burn completely. Okay. The next test we're going to do is we're going to take our product that we've done from combustion, and we're going to put in our lime water. Lime water is colorless, and when it mixes with carbon dioxide, CO2, it turns to a white or a milky color. This is because of the formation of the insoluble substance calcium carbonate. You would have learned that in the previous video, okay? So it's the same process as the previous video. When you mix lime water with carbon dioxide, it forms a white or milky color. And that would happen here in the test for carbon dioxide. The next test that we're talking about is the same as the previous experiment as well. It is a test for unsaturation. Test for unsaturation. And you can do this with either bromine water, which is a red or a brownish color, or you can do it with acidified potassium permanganate. Again, we went into more detail in these reactions in the previous video, but when we take our bromine water like this and we add it to Ethine, add it into a test tube of Ethine, Ethine is an unsaturated compound. When we react bromine with an unsaturated compound, it turns from red or brown to a colorless. So this shows us that the bromine has reacted with an unsaturated compound, Ethine. If there's no Ethine present, the bromine won't react with it and it will stay red or brown. The acidified potassium permanganate works using a similar idea. We add it into the Ethine. So we've got another test tube of Ethine that we've collected. And if it does react with an unsaturated compound like Ethine, then again, it changes from a purple to colorless, showing that it has reacted with an unsaturated compound. And that shows us that Ethine is unsaturated. Right, some questions now. I'm sorry, that was a bit quicker than the previous video. I'm assuming you watched the production of Ethine first. If you haven't, you probably should go and do that, and you'll learn more about those two reactions. So last question, last set of questions now I want you to do is this one's here. Okay, so pause the video and do them questions now. Okay, so you should only be watching the video again if you have answered questions 1 to 9. Okay, coming up now are the answers to them. Okay, so what is combustion? Combustion is burning. What is the gas required for combustion? That's oxygen gas. Number 3, the products of any fuel are always carbon dioxide and water vapor. Write a word equation for this reaction. So this would be, we're reacting Ethine. plus oxygen, and we're getting carbon dioxide plus water. Question 4 asks for a balanced symbol equation. All right, Ethyne C2H2 plus oxygen O2 gives you CO2 plus H2O. Those are the symbol equations for each of them. See here that I have so has that fixed my issue? I've got 2 carbons on the left, 2 on the right. I've got 2 hydrogens on the left, 2 on the right. I've got 5 oxygens on the left, and I'm going to have 2.5 on the right, like this, 2.5. Now, I don't like 2.5s like that. So if I double everything, it'll get rid of the half. So I have to double everything to get rid of the half here. So this is now going to be like this. It's going to be 2. This was 2.5, so this is now 5. This was 2, so it's now 4 because I'm doubling everything, remember? And then this would be a 2. So well done if you managed to do that. And the rest of those there are pretty straightforward. I don't think we need to explain those, so I'm just going to leave them there for you to make the corrections to your own answers. Okay, that is those 2 experiments now, the production of ethene in the first video and the production of Ethyne in the second video, pretty well summed up. Okay, so you're ready now to start doing some exam questions. So I will see you in the next video where we discuss another organic experiment.